1. Introduction, a mirage of ice. Imagine standing alone in the heart of a vast, scorched desert, a place where the sun feels close enough to touch, where the heat presses against your skin like the breath of a furnace, and where the air itself trembles at 40, 50, even 55 degrees Celsius. Your throat dries instantly. Every breath tastes like dust, and the horizon wavers in waves of shimmering heat. But then, as you crest the next dune, something impossible appears. A towering dome of sun-baked mud rises like a monument from another world. You step closer, unsure if the heat is playing tricks on your eyes. Yet when you reach the entrance and look down into the hollow darkness below, you see it. A massive pit filled with glistening solid blocks of ice. Not melting, not dripping, just frozen, perfectly preserved. There are no power lines, no humming compressors, no hidden machinery. Only desert wind, ancient clay, and a miracle of engineering. You have just discovered the Persian Yakhchal. Welcome to Historia Prime. Today we journey deep into one of humanity's most astonishing survival inventions, a technology so elegant, so ahead of its time, that it allowed ancient Persians to make and store ice in one of the hottest environments on Earth. Over 2,400 years ago, they mastered a system that behaves like a natural refrigerator, one that uses no electricity, no fuel, and no moving parts. Only math, physics, and an intimate knowledge of the desert. How did a civilization surrounded by burning sand produce ice thick enough to last through the summer? How did a building made of mud, ash, and even egg whites keep its interior colder than the outside world for half a year? And perhaps the most important question, what can this forgotten masterpiece teach us today, when modern cities struggle with rising heat and soaring energy demand? Stay with us as we uncover the secrets of the cosmic refrigerator, the ancient Persian Yakhchal, and explore how its timeless wisdom might point the way toward the sustainable, net-zero cities of our future. The desert is waiting, the ice is real, and the story is just beginning. 2. What is a yakchal? The name and the legacy. To understand the brilliance of this ancient structure, we must begin with its name, a name that has survived across centuries, languages, and empires. In Persian, the word yak means ice, and chal means pit. Together, they form a simple phrase, the ice pit. But behind that simplicity lies one of the most sophisticated cooling systems ever created by human hands. Because a yakchal was not just a storage room, it was not a pantry or a cellar or a crude attempt to keep food cold. It was, in every sense, a finely tuned thermodynamic machine, designed to capture the coldness of winter nights, to trap it, to protect it, and to store it as if it were treasure. And for the people of ancient Persia, ice truly was a treasure. In a world where summer could scorch the earth and twist iron in the sun, ice meant survival. It preserved food. It cooled feverish children. It allowed the wealthy to host gatherings with chilled sherbets and cold drinks, symbols of refinement in a harsh climate. When we trace the roots of the yakchal back through history, the trail stretches over 2,400 years. Archaeologists believe these techniques may have existed even earlier than 400 BCE. Through the Safavid era, through the Qajar dynasty, and across the rise and fall of kingdoms, the yakchal remained. It stood in the skylines of desert cities like Yazd, Kerman, and Kashan, its tall conical silhouette as familiar as a minaret, as constant as the desert itself. And perhaps the most astonishing detail of all is that the word has never disappeared. Even today, in modern Iran, Afghanistan, and Tajikistan, when families open their electric refrigerators, they don't say fridge, they say yakchal. Think about that for a moment, a term born in the ancient desert, describing a structure made of mud, ash, and lime, is still the everyday word for a modern machine, powered by electricity and coils and refrigerants. It is as if the past never left, as if the ancient engineers carved their wisdom so deeply into the culture that even technology couldn't erase it. The yakchal is not just an artifact, it is a legacy, a bridge connecting us to people who understood something we are only beginning to rediscover. That true sustainability lies in working with nature, not against it. And now, as we step deeper into this story, we will see how their genius took form in the very architecture of the desert. 3. Anatomy of a desert freezer. The 3 essential parts. To understand why the yakchal could perform the impossible, we must look beneath its surface. A yakchal was never just a building, it was a complete cooling system, engineered with precision and intention, where every structure played a vital role and every component worked in harmony with the others. And when you see how these pieces fit together, you begin to realize that ancient Persian engineers were not simply building storage, they were building a machine. Let us begin with the first component, the one that makes all the others possible: the shade walls. These walls were massive, stretching as long as 50 meters and rising nearly as high as a modern 5-story building. They were aligned with absolute precision from east to west, not by accident, but by astronomical design. In the northern hemisphere, this orientation casts a permanent shadow on the wall's northern side throughout the winter months. And in that shadow, something extraordinary happens. The ground becomes 15 to 20 degrees cooler than the sunlit desert around it, forming a natural cold zone. It is here, in this artificial night carved out of daylight, that the first step of ice making begins. Just beneath this band of chilled darkness, Persian workers dug shallow pools only 40 or 50 centimeters deep. At night, fresh water flowed gently into them through ancient Qanat tunnels, subterranean aqueducts that carried snowmelt from distant mountains across miles of desert. Even when the air hovered above freezing, at 5 or 10 degrees Celsius, the water in these pools froze. It froze because it could shed its heat directly into the immense cold of the night sky, and because the shade walls protected it from every stray ray of winter sunlight. By dawn, a thin sheet of ice formed across the surface, and as each night passed, layer after layer was added until solid blocks could be harvested like crops from a frozen field. But making ice was only half the battle. Keeping it frozen for 6 months under the blistering summer sun required a masterpiece of architecture: the conical dome and the reservoir beneath it. This towering dome, often 18 or even 20 meters tall, was not built for beauty, though its silhouette dominates the skyline like a desert pyramid. It was built for function. Beneath it, a deep pit dropped 6 meters into the earth, capable of holding thousands of cubic meters of ice. Its thick, sweeping walls served as both insulation and armor, protecting the precious cold inside. And its tall, tapering shape created a perfect solar chimney. As warm air rose, it escaped through a small vent at the top, while the heavier, colder air settled deep into the pit, embracing the ice like a protective shroud. Every angle, every thickness, every shadow was part of the design. Nothing was accidental, nothing was wasted. And when all 3 parts, the shade walls, the ice pools, and the great dome above the reservoir, worked together, they formed a machine so efficient that it performed a miracle. It froze water in the desert. It held ice through summer, and for thousands of years it stood as proof that with enough understanding of nature, humans can bend even the harshest environment to their will. Now that we've seen the anatomy of this ancient cold forge, the next question becomes even more fascinating. How did these structures not just survive the desert, but defeat it? 4. The secret sauce, the miracle of Suruj. To understand how a yakchal could stand tall in the desert for centuries, unshaken by earthquakes, untouched by floods, and unfazed by the brutal heat, you must examine not just its shape, but its skin. Because the true magic of this ancient freezer lies in the material that held it together, a substance so strange, so ingenious, and so unexpectedly effective that modern engineers are still trying to replicate its performance. That material was called sarouj. At first glance, sarouj looks like a humble plaster, but its properties were nothing short of revolutionary. Imagine a mortar that is waterproof, heat-resistant, and practically immune to cracking. Imagine a building material so durable that some structures made from it are still standing after more than 1,000 years. And imagine all of this created without factories, without steel tools, and without a single modern chemical. The recipe reads like something from an alchemist's workshop rather than a mason's notebook. It begins, as many great materials do, with lime and clay forming the structural backbone. Then comes ash, acting as a powerful thermal insulator that slows heat transfer to a crawl. Sand and water bind the mixture together, giving it body and weight. But the true genius emerges in the final ingredients, the organic additives. Persian builders added goat hair or camel hair, each strand reinforcing the mixture like modern fiberglass. Under the stress of desert heat, the flexible fibers prevented cracks from forming and spreading, giving the walls the strength to expand, contract, and endure. And then, perhaps the most extraordinary touch, came the egg whites and milk. When the mortar dried, the albumin from the egg whites hardened into a smooth, nearly glass-like surface. This made the interior of the yakchal completely impermeable to water, a crucial detail, because if melting ice seeped into the walls and froze again, the expanding ice would rip the structure apart from within. Instead, sarouj formed a seal so strong that water simply slid across its surface, unable to penetrate. At the base of the dome, the sarouj walls could be up to 2 meters thick. Such massive insulation created a thermal buffer so effective that it could take nearly a full year for the desert heat to creep from the outer surface of the dome to the inner chamber. In a land where temperatures soared high enough to warp metal, the ice inside remained shielded safe, cold, silent. Sarouj wasn't just a building material, it was a miracle of chemistry, centuries ahead of its time. It allowed the Persians to construct not just shelters, but machines. Machines that manipulated temperature, controlled moisture, and preserved one of the desert's most precious resources. And now that we understand the armor that protected the yakchal, we can finally ask the question that seems to defy logic. How did this ancient structure make ice without electricity in the first place? 5. The cosmic refrigerator. How does it work without electricity? Now we arrive at the heart of the mystery. It is one thing to store ice in the desert, but how did the ancient Persians make it in the first place, especially when winter nights could still hover above freezing? How do you freeze water when the air around you sits at 10 degrees Celsius? The answer lies not in the wind, and not in the soil, but in the sky itself. It begins with a phenomenon modern scientists call radiative sky cooling, a natural law of physics that the Persians understood intuitively more than 2 millennia ago. When the desert night falls, the sky becomes a vast, open gateway to outer space. And unlike humid climates, where water vapor traps warmth close to the ground, the dry Persian desert offers almost no barrier at all. Here, any surface exposed to the night sky, stone, sand, or water, begins to release its heat upward in the form of long-wave infrared radiation. That energy escapes through what researchers now call the atmospheric window, an invisible channel between 8 and 13 microns wide. Once the heat leaves, it does not bounce back. It does not linger. It simply disappears into the cosmos. And so the water lying in the shallow Yakhchal pools cools with astonishing speed, dropping 10, 12, sometimes 16 degrees below the temperature of the surrounding air. It freezes not because the air is cold, but because it is radiating its warmth straight into the infinite cold of the universe above. In a sense, the Persians were making ice using the night sky as their freezer. But this cosmic process was only the first layer of their mastery. Many yakchals were also crowned with badgirs, tall wind-catcher towers that performed a second miracle. These towers reached upward like open palms, summoning even the faintest desert breeze. When the wind entered, it was channeled downward through narrow shafts, often passing over underground qanats, streams of icy water drawn from distant mountains. As the air brushed across the water, it cooled rapidly through evaporation. Then, chilled and heavy, it flowed into the dome like a protective breath. Inside the reservoir, the stack effect completed the system. Cold air, being denser, settled deep into the pit where the ice was stored, while any warmer air rose and escaped through a small vent at the top of the dome. The entire structure became a living organism, breathing in cold, exhaling heat, and maintaining a perfect balance without a single mechanical part. No wires, no fuel, no electricity, only physics, perfected by ancient minds who studied the desert long before thermodynamics had a name. And as the Yakhchal continued this quiet, steady dance with the cosmos, block after block of precious ice remained frozen, protected through the unforgiving summer by nothing more than architecture, airflow, and the laws of nature themselves. Now that we understand how this cosmic refrigerator worked, the next chapter takes us into the heart of its purpose, the ritual of gathering the ice that would sustain an entire community through the burning season ahead. 6. The Ice Harvest, a community ritual. The ice harvest in ancient Persia was never just a technical task. It was a moment the whole community waited for, a brief window in the coldest days of winter when nature finally allowed the yakchal to do its work. Each night, workers filled the shallow pools beside the shade wall with a thin layer of water. By dawn, a delicate sheet of ice had formed, frozen not by the cold air, but by the night sky pulling heat upward into space. As the first light touched the desert, teams moved quickly. They cracked the surface with simple tools, lifted the thin slabs, and carried them into the yakchal's deep, echoing pit. Inside the dome, every piece of ice was stacked with precision. Straw, reeds, or sawdust were spread between the layers so the blocks wouldn't fuse into a single, unbreakable mass. This simple insulation ensured that months later, in the height of summer, the ice could still be separated and used piece by piece. The work continued for 8 days and nights, and when the pit was finally full, the entrance was sealed with mud and straw. Darkness wrapped the reservoir, and the desert heat could no longer touch it. What remained inside was more than frozen water. It was the community's insurance policy for the scorching months ahead. A silent reserve of cold, patiently waiting for the moment it would be needed most. 7. Luxury in the heat, sherbets and faluda. When the brutal heat of summer returned, the Yakhchal transformed from a silent winter vault into the most valuable building in the entire city. This was the moment everyone waited for. The Ice Master, a role of great responsibility, would finally unseal the dome's thick mud door, releasing a breath of cold air that felt almost miraculous in the desert's blazing heat. From the darkness below, blocks of ice, stored for months with care, were lifted out and loaded onto donkeys. They made their way to the bazaars, where people of every class gathered. And unlike many luxuries of the ancient world, this one was not reserved for the rich. Because the Yakhchal system was efficient, communal, and powered entirely by nature, even the poorest families could afford a cup of cool water in the middle of the desert. Travelers of the 17th century, like Jean Chardin, wrote in astonishment about walking through Persian markets and finding stalls selling ice-cold fruit juices, chilled sherbets, and drinks poured over crushed ice right in the heart of summer, when temperatures outside could scorch bare skin. And from this tradition came one of the world's oldest frozen desserts, faluda. Imagine a bowl of delicate, half-frozen vermicelli noodles made from starch, soaking in a syrup of rosewater and lime, then crowned with snow-like ice flakes shaved from the yakchal's ancient reserves. It was refreshing, fragrant, and utterly impossible without the desert freezer that made it all happen. In that moment, the yakchal became more than a survival tool. It was a statement, a bold reminder that even 2,000 years ago, people refused to let their climate dictate the limits of their comfort or imagination. Through ingenuity alone, they created coolness in the heat, luxury in the hardship, and sweetness in the desert's most unforgiving season. And soon, this remarkable innovation would teach us even more, not just about ancient cravings, but about our modern struggle for sustainable cooling. 8. Lessons for today. Beyond the mud walls. Why should a structure made of mud, straw, and egg whites from 400 BCE matter to us today? Because we are now facing a challenge even greater than the desert heat, a global energy and climate crisis. Around the world, cooling systems, air conditioners, refrigerators, industrial chillers consume nearly 10% of all electricity. And in summer, during heat waves, that demand can surge to half of the entire grid's load. Yet, 2,000 years ago, people living in one of the hottest regions on Earth created cold without using a single watt. That is why modern scientists and engineers are turning back to the yakchal, because it embodies principles we desperately need today. For example, SkyCool Systems, a technology company in the United States, has developed a multi-layer optical film that works on the same principle as the ancient cosmic refrigerator. This material reflects 97% of sunlight and radiates heat directly into space. Without consuming electricity, without using water, and without mechanical parts, it cools buildings and reduces energy use by 15 to 20%. These panels are already being installed on the roofs of supermarkets in California. Architects are also rediscovering ancient wisdom. They are using thick thermal mass walls to stabilize indoor temperatures, and they are reviving wind catcher designs, modern versions of the Persian badgear, to funnel cooled air into schools and offices. These buildings can remain comfortable at 40 degrees Celsius with no air conditioner running at all. The yakchal reminds us of a simple but powerful truth. The best solutions often come from working with nature, not against it. When we understand physics instead of fighting it, we can cool spaces without draining the planet's energy. And as the climate warms, these lessons become more urgent than ever. The mud domes of ancient Persia may look primitive, yet inside them lies a blueprint for the sustainable cities of tomorrow. 9. Conclusion. The future is ancient. The story of the Persian yakchal is not simply a chapter of ancient engineering. It is a reminder of what human ingenuity can accomplish when it aligns itself with nature instead of overpowering it. These towering domes, built from mud, ash, lime, and egg whites, stand as proof that mastery of the environment doesn't always come from machines, fuel, or technology. Sometimes it comes from understanding the world deeply enough to let it work for you. As we step into a future where energy grows more precious and heat becomes more extreme, the question we must ask is simple. Are we wise enough to look back? Can we build cities that cool themselves the way yakchals did, by radiating heat into the night sky, by harnessing the wind, by using materials that last centuries instead of decades? The next time you reach into your freezer and pick up an ice cube, pause for a moment and imagine those massive silent domes rising out of the Persian desert. Imagine the engineers who learned to freeze water under a sun that could melt metal, using nothing but the laws of physics and the coldness of the universe itself. They did not wait for modern solutions. They created their own. Thank you for watching Historia Prime. If this journey into ancient desert ice has inspired you, don't forget to like, subscribe, and tap the bell icon so you never miss our next exploration. And now a question for you. If you were stranded in the desert, which ancient cooling technique would you choose first? A wind tower or a yakchal? Share your thoughts in the comments below. Until next time, keep exploring, keep questioning, and keep learning from the masters of history.